Hey everyone, this video is a self-quiz over the topics of enthalpy and specifically some of the topics we've covered in Hess's law. There's going to be a little bit in here about delta HAC and delta HF, but not a lot. So make sure you have a pencil and a calculator and are ready to go. So here we go. Here's the problem. Consider the reaction given there. Calculate the delta H of this reaction using the following given reactions. Then you're going to come back and circle the reaction and delta H value that corresponds to the delta HAC of H2S2 aqueous. And then based on that data, what's the bond energy of S2? All right, so go ahead, pause the video, read through it again. You won't need a periodic table, just a calculator. Take a few minutes to try to do this on your own. So hit the pause button. All right, hopefully you have answers to all of these, and if you don't, feel free to, if I give you a hint here as I'm working through the solution that gives you enough to finish, go ahead and hit the pause button then, and work through as far as you can. This sort of thing does not work if if you're just watching this, it's not going to lead to you understanding. You've got to do as much work as is possible for you right now. So, all right, so we're going to go through this first part. This first part is a Hess's law problem, right? Because we're given reactions, and we're going to see if we can get them to add up. Remember, Hess's law says if you can add the reactions, you can add the delta H's, because delta H is a state function. It doesn't matter what path you use to get there. So I'm going to switch. I've copied over this first part here, and I'm going to switch my pen color. I need to have two H2S in the reactant side. The given reactions, I have H2S2, excuse me, I said H2S, I meant H2S2. I have it here, but it's on the wrong side, and there's only one of them. So I'm going to flip it and multiply it by 2. All right, so I'm going to do 2 H2S2 aqueous yields. That's going to give me 4 hydrogen atoms and 4 sulfur atoms. And because I've flipped the delta H, and I have multiplied it by 2. I've got to flip the sign of my delta H, so that's now going to be positive, and it's going to be twice as big, so it's going to be 2250. Okay. And these are all kilojoules per mole, so I'll come back and deal with that, the units at the end. All right, so now what's next? Now I need to have 2 H2S on the product side. I'm given one that has it on the reactant side, but there's only one, so I'm going to do the same thing. I'm going to flip and multiply by 2. So that's going to give me 4 H gas plus 2 sulfur gas yields 2 H2S liquid. So those are all on the right side now. So that's going to make that positive 1940. Now I've got S2 gas, and S2 gas, it's on the right side, has the correct stoichiometry, or coefficient. So we're going to just copy that one down. We're not going to make any changes whatsoever. These are all delta H knots. We're not going to make any changes whatsoever to those. All right. Now we're going to double check that we can add the reaction and get the one we want. So we notice that we've got 4 hydrogens here and 4 hydrogens here, so those are going to drop out. If you're making 4 hydrogens and immediately using them, it's like they were never there. You've got 4 sulfurs here. Notice that we have 2 sulfur gas, so that adds up to 4. So that all drops out. And that's going to leave us with, I believe, the reaction we were trying to get to, which is H2S2 aqueous yields 2 H2S liquid plus S2 gas. And so we've this checks out with our given reaction that we were trying to get to, so yay. Somewhere here there's a liquid instead of a aqueous. Did I make a mistake? Yeah, I did. I gave you the liquid one here instead of the aqueous. We're going to pretend that we didn't notice that, okay? So, did I give it to you as liquid up here? Oh, I just copied it down wrong. That's why. Nope, I just made a mistake. It's okay. We're going to run with it and pretend that these are aqueous. Okay. La-di-da-di-da. Okay. Okay, so If you caught that, good job, because I did not until just now. All right, so we've added up our equations. That means we can add our delta H's. Let's see. What did I do with my calculator? I had one out just for this reason, so that I wouldn't make a mistake. Here we go. I know it stresses everybody out when I make a mistake on the answers because they feel like they did it wrong, and it ends up being just something stupid I did. Okay. So I get a delta H of positive 3935, and that's going to be kilojoules per mole because all those were in kilojoules per mole. All right, so yay. All right, let's go back here. What was the next part of this? Circle the reaction in delta H value that can corresponds to the delta H AC of H2S2. So remember that AC stands for atom combination. So we're looking for atoms combining that turn into H2S2, and that's going to be right here. Use a slightly different color. So this is going to be part B. The answer is right here, right? Because I have atoms in their gas phase combining to form the compound. So the delta HAC of H2S2 is this value. So we could just call that delta HAC. And then we're asked the last question, what's the bond energy of S2? Remember that the bond energy is how much energy it would take to break a bond. It's basically the opposite of the delta HAC. You'll notice that in this next reaction, I need another color, goodness. This next reaction down, I have two sulfur gases turning into a sulfur 2 molecule. And if that's the case, that means that that 255 kilojoules per mole is released when that bond is formed. So if we were going to break it, would be the opposite of that, right? So the answer to part C is that the bond energy for S2 gas is going to be positive 255 kilojoules per mole, all right? And if you go back and check in your table of bond energies, you should, the S to S single bond should be somewhere around this number. Remember, those numbers are averages, so they're not going to be exactly this, but that should be within the vicinity of each other, okay? All right, so this has hopefully been helpful for you. If you have questions, please leave them in the comments or get in touch. And thanks for doing the quiz. See you soon.